to the inaugural video for the Whitetail Industries YouTube channel. Today's project was going to be about building a new bellows plate that's going to go into this major project for the C-beam upgrade project. However, while I was doing the cam work, I forgot that I had just put together a new computer and forgot to check the post processor. And I went through a few Endmills, so, well, lesson learned. Check your post processors. As you can see, well, that end mill went flying about 5-6 inches from where it was located. So today I'm gonna instead give you a little bit of an overview of what I've already done to my C-beam to make it more rigid to the point where it can actually machine metal a lot better. And I'm also going to go over the design of the project and the cam work that I've done so far. Alright, so this is my C-beam. I built this little enclosure for it with some acrylic front panel and what is this? I think 1/4-inch plywood. Doubled up the sheets of them a little bit in some places. It's actually a really sturdy box. On the base, I actually welded together a steel frame that the whole C-beam sits on, and it's all clamped together so that it doesn't vibrate as much. This machine now weighs about 150-ish to 200 pounds with all the added steel that I've added over the course of modifying this to work a lot more rigidly. I've also gotten rid of all the polycarbonate wheels and replaced them all with MGN12 linear bearings. There's more underneath here. There's just the bellows holding those in place. This is a 2.2 kilowatt spindle on an ER20 mount. It's probably a bit overkill for what this does, as it's mighty heavy, but it's also pretty rigid. I mean, it takes a lot of force to get this bit moving. Just because I also inset 40mm by 20mm U-channel steel plates into the centers of these, so all three axes have that, and it provides a lot of rigidity to this device now. And even on the back C-beams that are the vertical uprights, I also added those to that as well. And they're all cross-bolted in, and there's a screw every 4 inches holding those U-channels in place. So it's quite rigid. I'm going to bring you back inside and we will go over the CAD and CAM for the replacement plate and why I'm doing it. There's the display screen and there's the VFD, and right here it's got a Atomic Pi computer in it. That's what I run the CNC on. And also there's a OpenBuilds black box and a power supply in there. Alright, now that you've seen the C-beam and how I've constructed it so far, let's get more involved into this project. Here's the bellows plate that I was trying to make today, and that's the full project right here. Ironically, the bellow plates were the last thing I designed, but the first part of the machine, since that's the material I had in stock at the moment. So the first part that we designed is the actual carriage plate. It's got the holes for all 4 of the MGN12 trucks that ride on those rails. It's also got the holes for the 8mm lead screw bracket to tie into. And as you can see here, those are the mounting holes that holds the main fixture plate to this base. And you'll also notice there's 4 holes and 1 inset that are 1/4 inch. These are going to hold stainless steel precision ground dowel pins for locating and to ensure that the fixture plate stays square when I tighten down these 4 bolts. Let's pop up the fixture plate now, and this one's gonna be a bear to actually machine. I've got around 200 holes I got to machine. There's a couple pockets, and then some deep holes for the 3/16 or the 3/8 by 16 bolts to tie into. And here's right in this area right here is where the bellows will attach. And then together, that's just what it all looks like. Alright, so for the stock, I just measured my piece of stock, so it's 1 inch wide by 12 inches deep and 1/4 inch of thickness. So that's, and then pick the proper corners associated with the machine. And then the first operation is a 2D adaptive. I use flood coolant on the post processor because the way my spindle runs, I need to activate the relay to get it to turn on. So I have the relay tied in as the coolant. I manually turn the coolant on with air, and I will have a container of WD-40 when I really need it. But to be honest, I haven't really needed it much. A lot of the time I end up sticking the vacuum in there and just sucking up the chips. So I don't really need this function here, so I use it as a spindle relay switch because the open build black box has some issues. I set my clearances on the bottom. I always do a less 1/2 millimeter less than what your the bottom of the model. That way I make sure it breaks through cleanly in case there's any variation within the material, or I'm not quite perfectly flat on the plate. And I've got 2 pieces of blue painter's tape in between that and the fixture plate, so I'm not too worried about it digging through into the actual fixture plate itself. And then for the passes, I always do a multi-passes on everything because, well, it's still a router. It's not an actual CNC machine. So while real, like, say, a Grizzly or a Precision Matthews could plow through this in one pass, no problem, I unfortunately have a router which weighs still, even with all the stuff I've done, 1/4 of the weight that those do and probably about half the rigidity. So I go with 1/3 of a millimeter per step, and it seems to work pretty good when I'm not breaking end mills. And that's pretty much how I milled the pockets for those 5 holes. Those are 5 millimeter holes. There's clearance holes to hold the screws into the main fixture plate to hold the bellows in place. They just sandwich in. And then for the outer perimeter, pretty much the same deal. I'm doing a 2D contour this time, and you just basically select the outer edge. And on this one, I believe yes, I did also do a 1/2 millimeter below, just so you don't have any of those little strings of material left and fuzzies. And again, this is also a 0.3 depth of cut. Alright, let's simulate this machine operation. It's always good to simulate it, because if you don't, sometimes you can crash parts. So I always click stop on collision. It makes things much better. And I don't like showing the tool path. Well, let's show the tool path a little bit. Let's do a tail though, so it's not just completely blasting the area. And let's do material there so that you can actually see some stuff get cut. And I do a pull up here just to help chips evacuate, and so that there's no potential of any chip welding of the end mill into the aluminum itself. Other than that, this is a pretty basic hole operation, so let's speed this up a little bit. Look at that go. I wish my machine went that fast. And then that's just the outer contour, and you're done. And that was eBay. Let me know that HP printers are 30% off. According to Fusion, both these operations combined is going to take about 5 minutes per part to get made. I've found that this to be a pretty close. Usually it's a little longer than that. So I'd say around another minute. So I'd probably say this is about a 6-minute total operation between those 2 part operations being done. So to make the 2 bellow plates, it will only take about 12 minutes or so between, other than obviously putting setups and stuff. So I'd say probably about 20 minutes with setups and have those two fixture plates done for the, or rather the bellows plates done to attach to the fixture plate. They're a little bit of a tongue twister. Apologize for that. First video, all that good jazz. Alright, thanks for watching. Hopefully next week we'll get some chips flying. I should be getting some more Endmills in this weekend. And I will video while I'm machining the parts. I will also be receiving the material tomorrow to build the rest of those the main plates. So hopefully I'll be able to get those videos to you pretty quickly. I'm thinking probably one a week since I work and all that other stuff. Hope you enjoyed it. If you do, please leave a comment and talk to you next week. Bye. As a quick post-edit note, I realized I need to figure out why OBS isn't showing the sub-windows of Fusion, so I will try to get that fixed as well. Since I was doing the editing, I just noticed that none of the settings were showing up on the screen. Again, thank you, and talk to you next week.